All right, today we are going to look at some of our properties of exponential functions. We talked about we have our general form for an exponential function as y equals ab to the power of x, where the x value is our exponent. Today what we're going to do is we're going to look at, well, what happens if we change some things to this. It says, how does the graph of y equals negative 0.05 times 5 to the x compared to the graph of the parent function? Now our parent function would be something like y equals 5x. That's what we originally start with, and then now we're going to change things by multiplying it by 0.5. This right here is our graph of y equals 5 to the x, so we can compare this, and then this is our new graph. This is y equals negative 0.5 times 5 to the x. So we can compare this dotted line to this line right here. Now the first thing that we see is when we graph this, notice that we reflect. So this is a reflection of the parent function. And the reason that we have the reflection is because of this negative right here. Now our domain is our all possible x values. We talked about all of our x values for these will be all real numbers, and for both of these we can see our x values remain the same. So the domain of this is the same as the parent function. Now the range is our y value. In this case, our y value in our parent function is going to be all y values greater than 0. But for our parent function, because we reflected over that x-axis, they are now going to be the opposite. Or y is now less than 0 from the parent function. The y-intercept, remember the y-intercept is the number that we multiply, or the a value. So in this case, it's going to be at negative 0.5. And then multiplying 5 to the x by that 0.5 is going to compress it. You can kind of see up here it crossed. It's not a true reflection over the x-axis. It crossed at 1 here, but now it's crossing at 0.5. So it's going to compress the vertical scale. We can also look at some other properties of these functions. If we have our parent function here as y equals, in this case, it's going to be y equals 4 to the x is our parent function. We can see when now we're going to do something up in that exponent. We're going to add 2. So we want to see how that is going to compare. So the graph of y equals 4 to the power of x plus 2 is going to actually be a horizontal translation. Remember, back with our absolute values, when we did things to the x, it shifted horizontally. So this is going to be a horizontal shift, and we always do the opposite. So it's adding 2, so we're actually going to move to the left 2. If I was subtracting 2, I would move to the right. We do the opposite of what we see. Based on that information, we can sketch the graph of y equals 4 to the power of x plus 2 on the same set of axes, right next to this. So each time you see, and we can use our nice where it crosses at grid points and things like that, this is actually just going to shift our graph to the left 2 points because we're adding that 2. So 1, 2, it's going to be right here. This one's, so we can go 1, 2. It's about halfway at on the 2, so we can go 1, 2. Here's 1, 1, 2. We can try this one right here. Crosses. So 1, 2 right in here. And once we get our points, we can kind of sketch to see what that graph is going to then look like. It should look we connect these points. And so all this did by adding this 2 is it shifted our graph over 2 places to the left. So we're going to now create a table that kind of shows all of this together so we have it all in one place. So if you'll turn your page, our families of exponential functions, and this is going to be our graph with all of this information. So the first thing is our parent function. We have that y equals b to the x. We can stretch it by if that a value is greater than 1, and we'll say the absolute value of a is greater than 1. That's going to stretch our graph out. Compress it like we looked at earlier if that a value is in between 0 and 1, or it's and it's going to be the absolute value. If it's a fraction or a decimal in between 0 and 1, it's going to compress or shrink that graph. If a is negative, or a is less than 0, then that is going to reflect the graph over the y-axis where we got that other one. And then we have translations. If we do something to the h, in this case, h right here is going to be our horizontal, and we can shift it, translate it vertically, we can move it up and down by this k. So if we add or subtract something on the outside, that is going to affect our k value. So again, the a value can stretch or shrink based on if it's greater than 1 or if it's in between 0 and 1. If it's a negative, it's going to flip or reflect the graph, and then this k value is going to be a horizontal shift, and the h value is a horizontal shift, and the k value is a vertical up and down shift.